Bismillahirrahmanirrahim. Today we are going to speak about the derivative of functions or the derivative functions. Derivative of a given function sometimes is defined as the change of rate. If we find the difference between two values of the function divided by the difference between two given values of x, we have something called the mean of the function. So if we have a function, this is f of x. If we take the difference between 2 points on the curve, let's say f of a and f of b. F of a or f of b minus f of a divided by the distance between b and a will give me sometimes the average of the function, or just change between the 2 points. For example, if f is representing the distance, then f of b minus f of a divided by b minus a, where b and a are the time, we will have the speed. This distance divided by the time will give me the velocity or the speed of the moving object. If b minus a is very small, if the difference between b and a is very small or goes to zero, then we call that instantaneous change of rate, or the derivative of the function. So the derivative of the function will give me change of rate of the given function between 2 points. This is informal. The formal definition, we say that the function f prime defined by the formula f prime equal to the limit of f of x plus h minus f of x divided by h, where h goes to 0. So the function defined by this formula is called the derivative of the function f with respect to x, or the derivative of f. With respect to x, because we are looking for the change in the x variable. Our variable here is x plus h. We just change the variable x by a little amount, very small amount, which is, or a little value, which is x plus h. Small change of the value of x will give me small change of the value of the function. If we take the limit as h approaching 0, then we call that function is the derivative of the function. Or sometimes we call it also change of rate. Or sometimes called the slope of the tangent line. Slope of tangent line. We'll see this later on. So this is the derivative. And this formula, which is f prime equal to the limit of f of x plus h minus f of x divided by h, we call sometimes the first principle or the definition. the principle or the definition of the derivative. Now the domain of the derivative of f prime consists of on x in the domain of x, so in the domain of f, not x, for which the limit exists. Which means this condition of the limit there. If it exists, then we can say that we have derivative for the function. If the limit, this is f prime of x. If the limit exists, then we have the derivative. So this is in general or the formal definition for the derivative. It is equal to the limit of f of x plus h minus f of x divided by h, where h goes to 0. Let's apply this definition to find some derivatives. Or before that one, let's speak about the annotations. The derivative of the function, sometimes written as f prime of x or y prime of x, means the derivative or dy over dx, which is the derivative with respect to x, or df by dx. These are notations used usually or in general for the derivative of the function. If my variable is x, then it is df by dx or dy by dt. If my variable is time, I will write it as df by dt, depending on the independent variable that we have. Now, let's take this example. Find f of prime. We find the derivative of the given function using the definition. Because later on we will see that we have different techniques to find the derivative. But for the topic today, we are going to find the derivative using the definition. Example number 1. F of x equal to 3x minus 1. And I want to find the derivative of this function using the definition. The definition said that the derivative equal to the limit of f of x plus h minus f of x. So let's find f of x plus h first. F of x plus h means that we need to replace any x in the function by x plus h. Any x. So it will be 3 multiplied by, replace x by x plus h minus 1, which give me 3x plus 3h minus 1. Now I have f of x plus h. So the derivative of x is equal to limit of f of x plus h minus f of x divided by h, where h goes to 0. And this is equal to limit f of x plus h, which is this one, will be 3x plus 3h minus 1 minus f of x, which is 3x minus 1. And to avoid any mistake, I will put it in a bracket. Divided by h. Because we have to change the sign. Why this goes to 0. Now if we simplify this one, we'll have limit. This is 3x plus 3h minus 1, open the bracket, will be minus 3x plus 1, divided by h, where h goes to 0. And you can see 3x will cancel 3x minus 1 with the plus 1. So the remaining will be limit 3h over h, where h goes to 0, and h will cancel h. So I will have 3 only. So we'll say that the derivative of this function is equal to 3. This will be the derivative of the given function, f prime of x equal to 3. Let's take another one. Example number 2. To find the derivative for this function, which is x squared minus 4x plus 5. Let's find the derivative of this function, x squared minus 4x plus 5. As we said before, let's find f of x plus h first. It means replace any x by x plus h. So the first one, x plus h all square minus 4 multiplied by x plus h plus 5. We have this identity, which is a plus b square is equal to a square plus 2ab plus b square. I'm going to use it to open the first bracket. So this is equal to x square plus 2xh plus h square. Open the second bracket, that will be minus 4x minus 4h plus 5. So this is f of x plus h. Now let's find the derivative. F prime of x is equal to small one, it is equal to the limit f of x plus h minus f of x divided by h, where h goes to 0. This is equal to x square plus 2xh plus h square minus 4x minus 4h plus 5. This is the first part, which is f of x plus h, minus f of x, which is equal to x square minus 4x plus 5, and put it in a bracket. So that we need to change the sign, and the coming step, that will be minus x squared plus 4x minus 5. Okay, the limit over h, where h goes to 0. Now, see, I have x squared will cancel minus x squared. Minus 4x will cancel, minus with minus will be plus, so we'll cancel this one. And 5 will cancel minus 5. So I have now the limit of 2xh minus 4h divided by h, where h goes to 0. Now if we replace h by 0, I will have 0 over 0, which means that I need to simplify it. So this is equal to the limit. For the numerator, I'm going to take h as a common factor. So I will have 2x minus 4 divided by h, where h goes to 0. So I forget to write this h. I have h there. That will be plus h squared. So this will be plus h. Now I have h as a common factor from the numerator. I will get h multiplied by 2x minus 4 plus h, where h goes to 0. So I will cancel h up with h down. And this h is equal to 0 as per the limit. So it is limit of 2x minus 4 plus h, where h goes to 0. Just replace h by 0. I will have 2x minus 4. So the derivative function, now f prime x equal to 2x minus 4. So this is the derivative of this given function. It is f prime of x equal to 2x minus 4. Let's take one more. Number 3. F of x equal to square root of x. Let's find the derivative of this function. First of all, I need to find x plus h. F of x plus h. Means replace x by x plus h. So this is equal to x plus h, square root of x plus h. Now the derivative is equal to the limit f of x plus h minus f of x divided by h, where h goes to 0, which is equal to, this is the limit of square root of x plus h minus square root of x divided by h, where h goes to 0. And if we replace h by 0, I will get 0 over 0, which means I need to simplify this function by multiplying by the conjugate. So I need to multiply this by conjugate to simplify it. The conjugate is square root of x plus h plus square root of x up and square root of x plus h plus square root of x down. So I just multiply by the conjugate of the numerator by changing the sign. It is minus, I will write it plus. This is the conjugate of the numerator. Now multiply, we will have limit of, this is a minus b multiplied by a plus b, which is equal to a square minus b square. So it is the square of the first part or first term minus the square of the second term. So I will have square of x plus h whole square minus square root of x whole square divided by h multiplied by x plus h plus square root of x. Let's go to 0. And you know that square will cancel the square root. So I will have in the numerator, it is the limit of x plus h minus x divided by h multiplied by square root of x plus h plus square root of x as h goes to 0. X, cancel x. So I will have now this h divided by h multiplied by square root of x plus h plus square root of x as h goes to 0. Now I have h as a common factor between the numerator and the denominator. So this h will cancel h. I will have 1 up in the numerator divided by. Now if h equal to 0, the first term will be only square root of x plus the second one, which is also 1 over x, and that will lead to the derivative of the function, which is equal to 1 over square root of x plus square root of x is equal to 2 square root of x. So the derivative of the function f of x equals square root of x equal to 1 over 2 square root of x. The derivative of of the square root of x will be 1 over 2 square root of x.